Hi, I'm Brian with Pioneer Builders. I'm a second-generation builder, and this channel is devoted to all things building. In a recent project, the plumber took out two sections of a top chord of an I-joist, thereby damaging that joist. So we submitted it, and we're wanting to double-check and make sure that the joist hadn't been overly compromised and whether or not a repair would be needed. Thankfully, no repair is needed, but I wanted to walk you through the report and show you some of the different components if such a thing happens to you. If you're like me, sometimes when we're not very conversant in something, it can be overwhelming, and we might have a tendency to just pass along the report, or dare I say, not even ask about it anyway, and some people might just wait to see if the inspector catches it. Well, in this case, we got our framing inspection, and the inspector didn't catch it. I didn't know about it either until I started examining matters more closely. So, while the inspector isn't requiring this, for my own peace of mind and conscience, I wanted to get it checked out. I'll walk you through some of the different sections of this report. I'm not a structural engineer. However, I can definitely understand the basics of structural engineering, and if there's anything at all that I'm saying that's inaccurate or technically incorrect, I would love a correction in the comments below. So here's the drawing section of the I-joist. It's 13 foot 10 inches long. It's bearing on a 2x6 on the left and a 2x4 on the right. It's a double joist. You can see that here on the right side with a section view. That's what these X's are at the bottom. Those are the bottom chords. These are the top chords here, and then this would be the webbing. It's 1 foot 2 inches tall, or 14 inches. You can see where the damage was done with these two holes here in the top view. You can see the foot in inches, then the inches, the foot in inches, and then the inches, where both of these holes took place. In the cross-sectional view, you can see that they've isolated the chord that had been damaged. Notice they say varies from 1 inch to 1.5 inches. As we go lower in the report, we'll see the member information. This is where we find out about what some of the givens are, what some of the factors are when it comes to the I-joist. So we can see that the type is a joist, it's a double. The spacing is 24 inches on center. Dry. Deflection live load denominator of 480. The higher this number, the stiffer it's going to be. And then the deflection total load of 240 for the denominator. The importance factor is 2, or normal. The temperature was less than or equal to 100 degrees. The floor live load, 40 pounds per square foot, and the dead load at 10. The application is a floor, the design method ASD, the building code 2018 IBC, load sharing no, the deck not checked. The reactions patterned pounds for uplift, bearing 1, bearing 2, the direction is vertical bearing. There's a live load of 560 and a dead of 140. Again, this is in the uplift patterned pounds for the reaction. The second one, 547 and 136. There was no snow, wind. I'm not sure what the CONST stands for. As I said earlier, not a structural engineer. For the bearings, we've got Doug fir on bearing 1. Bearing 2 is the same. The length is 5.5 inches. We know that because it's a 2x6. Then the 2x4 is actually 3.5 inches. The direction, again, is vertical. The capacity, 29% and 30%. We have a reaction, dead and live load, pounds of 140 and 560, and then 137 and 547. Adding these numbers together gives us a total live and dead of 700 and then 683. The location analysis is where those actual damages took place. So we have a positive moment, a shear, and a down deflection. Then that's repeated for the second location, which was at 4 foot 4.5 inches. positive moment, shear, and down deflection. The maximum value here is 1,121 feet per pound, or pound-feet. Again, I'm not sure. I'd love somebody to help me out. This is just a good start. And then the shear here is 460 pounds. And then the down deflection is 0.042. The positive moment, you notice as you walk down the joist, heading towards the center, that increases. So the one that was closer to the bearing point on the left side was at 1121. Now we come up to 1,836. This makes sense. The farther we get to the center of the joist, the more of this we're going to see. The shear is at 460 pounds, and that is at the closer end to that bearing point. With the joist, it's seeing more of a load for the shear side of things as it gets to the end supports. So as we get further from the end supports, it's exactly what we would expect. It's seeing less of a load at that point. And then the down deflection, 0.073. Here's our analysis results. You notice for the moment they're figuring it at 7 feet. That is about center of the joist. It's allowed this actual joist to see 8,880 pounds per foot there. The actual that it'll be seeing is 2,181 feet. When we come over to the location analysis and look at these two locations for where the damage took place, we can compare this 1,121 feet and this 1,836 feet and see that that is less than this 2,181 feet. That again is at its pretty much worst point when it comes to that moment. It would be allowed 8,800. When we divide 2181 into that, we're at about a 25% capacity anyway. Both of these numbers are less than that actual at its worst location, and so we're okay. When it comes to the shear now, they're using this location of 4 inches and 4 3/4 inches. Again, not a structural engineer, I keep repeating that, but my guess is shear, because it's worse at its edges, this is that location. So the actual for this joist would be 660 pounds. It's allowed to be 3,360 for this particular series of joist. We're at 20% capacity. So we compare that over to these other 2 points, and the shear at the closer one is 460. As we move more toward the center of the joist, the shear gets lower at 263. 460 and 263 is considerably less than that 660 pounds. Then as we go down, we see the live load deflection per inch, the total load deflection per inch at that 7-foot area. We are allowed this, again, that L divided by 480, which we get from up here. The total load, 240. We see that down here. And we look over here at the 0.042, the 0.073, and we are below in both of those. So thankfully this joist passed. Again, I may be missing some things here, but hopefully this will get you on the right path. If needed, you can talk to your I-joist company with a little bit more understanding of how to read this. And if you're dealing with your structural engineer, kind of the same thing. So hopefully that helps. Again, my name is Brian with Pioneer Builders. I'm a 2nd-generation builder. This channel is devoted to all things building. If you enjoyed this, go ahead and subscribe. Give it a thumbs up if you thought this was a good video. I'd love to hear your comments below. I am learning something every day as a professional builder. Give me a follow over on Instagram. My handle is Pioneer Builders Inc. Give my brother a follow too. Check him out on YouTube. He's our lead carpenter, does our structural concrete, our siding, and he is Awesome Framers, is his handle on YouTube and Instagram. Thanks for watching, and I hope you learned something.